The Khorasan Plateau occupies the northeastern corner of Iran with the specific indifference of terrain that makes surveillance difficult and supply lines long. The Iranian ballistic missile program had been using those distances for 14 years by the time the target folder reached the confidence level required for a targeting decision, using them not to conceal the program's existence, which was among the least concealed facts in the regional security environment, but to conceal a specific production capability whose range band represented a threshold the strategic assessments had been describing with increasing urgency, and whose production rate had been estimated with decreasing confidence for 3 years because the facility was underground in Khorasan, in terrain that made corroborating collection difficult to obtain and sustain. The facility was a complete manufacturing plant for a medium-range ballistic missile whose nominal range placed the entire Middle East, the Eastern Mediterranean, and the Indian subcontinent inside its coverage. A missile at that range band, produced at the intelligence's estimated rate, changed the strategic calculation for every partner nation and forward-deployed American asset within that radius. The assessment had been producing urgent language for 18 months. The targeting decision followed. What distinguished the Khorasan facility was vertical integration. Previous facilities in the series had been specialized: propellant at one site, guidance components at another, warhead integration at a third. Khorasan consolidated all 4 production steps under a single underground roof. The intelligence community's assessment of why was straightforward. Distributed production generates logistics signatures at multiple sites that collection systems are designed to triangulate. One integrated facility generates 1 signature. 1 is harder to read as a production program than 4. The consolidation created both a targeting efficiency and a challenge. A facility housing multiple production processes at different completion stages presented weapons employment requirements that differed by zone. The guidance integration area required direct contact detonation to eliminate sensitive electronics reliably. The propellant loading zone required a geometry that would initiate propellant without an uncontained surface event. The airframe assembly zone between them could be addressed by either solution's tunnel-transmitted effects. The weapons engineers developed an employment solution: 2 weapons, 2 aim points, guidance integration, and propellant loading, with the assembly zone addressed by combined tunnel effects from both detonations. The primary production chambers sat at 58 meters, consistent with the Iranian program's hardened infrastructure pattern. The substrate was consolidated silty sandstone, characterized from seismic monitoring data and subsurface samples. The silt content created layered density variations, producing deceleration anomalies at predictable intervals. Anomalies the fusing algorithm had been developed to recognize as geological features rather than errors. Validated against laboratory samples. Engineers assessed the solution at 84% confidence. 16% was document. The mission was authorized. The B-2 lifted off at 10:44 p.m. The routing to the Khorasan Plateau required 15 hours and 27 minutes, the longest flight time in the series, a consequence of Khorasan's northeastern position. 15 hours placed the crew at the release point at the outer boundary of physiological performance management. The flight surgeon's briefing had been explicit. The release phase would occur during maximum cumulative fatigue load, and the management protocols were mission requirements, not recommendations. The pilot had been flying this aircraft for 16 years. He had protocols developed across more extended sorties than the surgeon's database contained, consistent with the briefing and more detailed than it could provide. He managed. The first tanker contact at 2:31 a.m. completed in 18 minutes. The second at 10:08 a.m. east of the Strait of Hormuz placed the aircraft at its final fuel state before the penetration phase. EW package coordination confirmed through the data link during the second window. All assets in position, timing active, the signals intelligence platform showing a characterized picture of the northeastern interior. Characterized, not empty. The characterization was what the EW package had been built against. The Khorasan air defense sector was not the dense, purpose-built architecture of the nuclear sites or the capital region. Its threat assessment had weighted eastern approaches heavily and southwestern approaches lightly, the direction from which no collection system had flagged a consistent American operational pattern. The southwestern approach the mission used was not a gap. It was the thinnest coverage direction. The EW package had been sized to suppress thin coverage adequately. Long-range southwestern coverage came from a single S-300 battery near Variance, oriented at an azimuth that placed the mission's approach vector in its less sensitive sector, reducing detection probability at the B-2's radar cross-section profile. The Growler flight's suppression from the Gulf of Oman produced effectiveness the EW officer assessed as solid. The battery was managed. Inner coverage was provided by a Tor M1 that the target folder had placed at a garrison location 12 kilometers west of the facility. The garrison location was correct. The Tor M1 was not there. It was in a field position 3 kilometers south of the access point. Repositioned 9 days before the mission during a readiness exercise that the imagery collection had missed because the imagery pass was scheduled after the exercise ended. The repositioned battery's position was not in the EW allocation. The suppression the land-based EW asset was providing against the garrison location was covering empty ground. The B-2's passive warning receiver detected the repositioned Tor M1's emission at 1:14 p.m. local time, 31 minutes before the planned initial point. The emission was classified correctly, a Tor M1 acquisition radar in active search mode. But the geolocated position it produced differed from the target folder database by 3 kilometers. 3 kilometers south toward the facility's access point rather than away from it. The mission commander assessed the discrepancy in the time he had available. A repositioned Tor M1 3 kilometers from the facility's surface access point, in a position the land-based EW asset's current allocation was not covering, operating in active search mode at a range that placed the aircraft inside its theoretical detection envelope in 24 minutes. He transmitted the reallocation code to the land-based EW asset. The asset received the code and began redirecting its output from the garrison location to the repositioned battery's actual position. The redirection took 9 seconds to reach full effectiveness. 9 seconds during which the repositioned Tor M1 operated on a clear frequency. In those 9 seconds, the Tor M1 conducted 2 acquisition sweeps. The first sweep returned a contact at 17% detection confidence, below threshold, below the reporting threshold, logged automatically by the tracking processor. The second sweep returned a contact at 24%, also below threshold. The tracking processor generated a developing contact flag, not an alarm, not a reported contact, but an internal system indicator that 2 consecutive above minimum returns on the same bearing warranted continued monitoring. The flag was displayed on the operator's scope as a dim yellow indicator that the system's interface reserved for low-confidence developing contacts. The operator was scanning his full sector and had not focused on the bearing from which the returns had come. He noted the yellow indicator in his peripheral attention. He moved his focus to it at the moment the EW asset's reallocation reached full effectiveness and the third sweep returned nothing. The yellow indicator disappeared. The developing contact was downgraded to background. The operator had looked at an empty display where a dim yellow indicator had just been and registered the absence rather than the presence. His log showed no contact report for the period. The 9 seconds of clear frequency had produced 2 returns that the system had flagged internally and that the operator had observed only in their absence. The reallocation that had cleared the Tor M1's search frequency had drawn power from the S-300 suppression allocation, a trade-off the mission commander had accepted when he transmitted the reallocation code. Because the alternative was a repositioned Tor M1 with unrestricted acquisition coverage during the terminal approach. The S-300 suppression had dropped from the solid effectiveness the EW officer had characterized before the reallocation to a degraded level that the officer now characterized as adequate but reduced. Adequate but reduced against the less sensitive approach azimuth that the mission was using. The combination, reduced suppression against an already less sensitive exposure geometry, produced a detection probability that the mission commander computed from the numbers the EW officer was displaying on the data link. The probability was higher than the pre-mission planning had assumed. It was still below the threshold the planners had established as mission limiting. He continued. At 1:39 p.m., with the initial point 6 minutes ahead, the S-300 battery near Birjan produced a return on the B-2's approach track that the fire control system assessed at 36% detection confidence. The degraded suppression had not eliminated the battery's acquisition capability. It had reduced it to a level at which the B-2's radar cross-section profile at the current approach geometry, combined with the reduced jamming effectiveness, had crossed the detection floor that the pre-mission planning had calculated as the lower boundary of the less sensitive sector's coverage. 36%. The battery's automated system displayed the return to the engagement controller. The controller had been monitoring a sector that had been experiencing active jamming for over an hour, had received no prior contact reports, and was now looking at a single 36% return in a jammed environment. His doctrine was unambiguous about single below-threshold returns in jammed sectors. Log and continue monitoring. He logged it and continued monitoring. The second sweep from the S-300 occurred 18 seconds later. The return position had moved along the approach vector by a displacement consistent with a fast aircraft. The confidence level was 41%. The controller was now looking at 2 sequential returns, 36, then 41%, on the same bearing with a positional displacement consistent with a movement. His doctrine was equally unambiguous about 2 sequential returns with a consistent track development in a jammed sector. Supervisor notification and authorization request for fire control radar activation. He notified his supervisor at 1:39 p.m. and 52 seconds. The mission commander saw the S-300 fire control radar emit its first activation pulse at 1:39 p.m. and 58 seconds, 6 seconds after the controller's supervisor had received the notification and authorized the activation. Fire control mode. Active tracking. The aircraft was 4 minutes and 41 seconds from the initial point. The mission commander transmitted the maximum output code to the Growler flight. The Growler redirected all available power to the S-300 fire control frequency band. The redirection cost the remaining suppression on the Tor M1 garrison location, already covering empty ground, and drew from every secondary allocation in the Growler's output budget. Maximum output against the S-300 fire control frequency reached the battery in the time it took the electromagnetic signal to cross the distance between the Growler's position and the S-300's antenna. Speed of light, no latency. The S-300's fire control picture degraded within the first sweep cycle after the maximum output activation. The fire control radar produced one complete sweep in full effectiveness mode before the maximum output jamming reached it. That sweep produced a contact at 53% detection confidence, above the battery's engagement threshold. The engagement controller had an authorized engagement. His fire control computer was computing a firing solution from a single above-threshold return without the track continuity that a precise solution required. A single return above threshold authorized engagement, but did not guarantee a precise solution. His protocol for a single return above threshold engagement in an active jamming environment required supervisor authorization for launch. He requested the authorization. His supervisor received the request at 1:40 p.m. and 7 seconds. The supervisor looked at the engagement status. Single above threshold return. Fire control picture now degraded by maximum output jamming. Solution continuity 0. Approach sector over the Iranian interior with no corroborating contact from any other system in the sector. He had 9 seconds to decide before the engagement window that the fire control computer had computed would expire. He authorized the launch at 1:40 p.m. and 13 seconds. 2 missiles left the rails. The missiles flew on the single return fire control solution, a solution whose range estimate was ambiguous because a single return without track continuity could not resolve range through the standard Doppler triangulation method that the fire control radar used for precise engagements. The range ambiguity translated to a missed distance distribution that the mission commander could not compute from the cockpit because he did not have the fire control solution data. He had the missile uplink signatures on his passive warning receiver, and he had the geometry of the engagement. And from those 2 inputs, he computed the worst-case intercept geometry and determined that the worst case placed the warheads within a distance he was not comfortable with, but that his training and his experience told him was not an intercepting solution. He held his course. The release point was 3 minutes and 51 seconds ahead. He held his course. The Growler's maximum output jamming reached the missile uplink frequencies 11 seconds after the missiles launched. 11 seconds of uncontested uplink guidance, followed by degraded guidance as the jamming found the uplink band. The missiles continued on their last computed trajectory. The range ambiguity in the fire control solution had generated a trajectory that bracketed the aircraft's computed position at the solution's computed range. The bracket was wide enough that the B-2's actual position, displaced from the computed position by the range ambiguity error, fell outside the lethal radius of both proximity-fused detonations. Both missiles detonated at 1:40 p.m. and 51 seconds, 38 seconds after launch against empty atmosphere at the edge of the bracket. The concussion reached the aircraft as the low-frequency pressure signature that near-miss detonations produce at altitude felt in the airframe, noted, filed. The pilot held altitude. The mission commander confirmed the detonation locations on the threat display, both outside the engagement envelope. The aircraft continued. The initial point was at 1:43 p.m. and 19 seconds. The bay doors opened with the structural shudder that had never become irrelevant in 16 years of flying this aircraft, and that the pilot registered with the part of his attention that was not occupied by the instruments, the threat display, and the targeting system's GPS solution confirmation. The solution was confirming against the first aim point, the guidance integration chamber's subsurface coordinate, 93 meters from the airframe assembly zone, at a depth of 56 meters in the silty sandstone formation. The algorithm would count through 4 density variation layers before reaching the detonation threshold. It had been validated against 4 layers. The first GBU-57 released. The weapon's descent through the plateau surface and into the silty sandstone produced the layered deceleration profile the algorithm had been developed to recognize. First density variation at 11 meters, recognized, adjusted, continued. Second at 23 meters, that recognized, adjusted, continued. Third, at 39 meters, consistent with the Geological Survey's characterization of the formation's primary density boundary. Recognized. Adjusted. The fourth variation came at 49 meters, 9 meters shallower than the survey had predicted for this location within the formation. The algorithm had been developed to recognize density variations, but had been validated against the survey's predicted depths. A variation 9 meters shallower than predicted was within the characterization, uncertainty the engineers had documented, but at the boundary of it. The algorithm recognized the variation as the fourth feature and began the final depth count. The fuse threshold was met at 54 meters, 4 meters shallower than the aim point's design depth. The detonation occurred above the guidance integrations chamber's ceiling rather than inside the chamber itself, above the ceiling rather than inside it. The kill mechanism the weapons engineers had computed for the guidance integration zone was direct contact detonation, the precision required to reliably eliminate the sensitive electronics without the limestone ceiling absorbing and distributing the overpressure in ways that reduce the peak pressure reaching the equipment. A detonation 4 meters above the ceiling transmitted its energy through 4 meters of intact, silty sandstone whose acoustic impedance reduced the peak overpressure at the chamber by a factor that the engineers had modeled. The factor was sufficient to destroy the guidance integration equipment if the equipment's structural specifications were at or below the median of the range. The intelligence assessment had characterized: if the equipment was at the upper end of that range, if the integration racks had been built to more robust specifications than the intelligence had established, the transmitted overpressure might be insufficient for reliable elimination. The mission commander saw the telemetry, fourth density variation at 49 meters instead of 58, fuse threshold at 54, 4 meters short of design depth, kill probability on guidance integration equipment at upper bound specification, 63%. The second weapon was going to the propellant loading zone. Its tunnel-transmitted effects would not reach the guidance integration chamber at the threshold the kill mechanism required at upper bound specification. He transmitted the aim point modification before the decision had fully formed as a conscious thought. Second weapon redirected from propellant loading zone to a position 21 meters from the first weapon's impact point, placing the second detonation inside the guidance integration chamber. The modification cost the propellant loading zone. Unaddressed, it would survive in partially functional condition. The airframe assembly zone would receive tunnel-transmitted effects from the first weapon alone, reduced without the second weapon's contribution. The guidance integration zone would be addressed twice, from above by the first, from inside by the second. He transmitted the code. The weapons management system updated the aim point. The bay doors opened. The second GBU-57 released at 1:44 p.m. and 31 seconds, 72 seconds after the first. The recomputed aim point at 21 meters from the first impact was at a position where the geological density profile had not produced the shallow fourth variation. Different position, different density history, design depth achievable. The weapon reached 58 meters and detonated inside the guidance integration chamber. The overpressure at direct contact geometry was not a function of the equipment's specification range. It was a function of physics. The combined effects addressed the guidance integration zone comprehensively. The tunnel transmitted energy into the airframe assembly zone. Extensive structural damage, not total elimination. The propellant loading zone absorbed tunnel-transmitted energy sufficient to damage the loading infrastructure without initiating the propellant. The propellant survived. The equipment that would have loaded it did not. The guidance systems it would have been mated to were gone. The production sequence was broken at 2 of 3 stages. The third stage's propellant had nowhere to go through a process that no longer existed. A production facility broken at 2 of 3 sequential stages is not a functioning production facility. It is a building with materials that cannot move through a process that no longer exists. At 1:45 p.m., the facility's monitoring system registered seismic alarms across all production zones simultaneously. The duty supervisor contacted each zone: guidance integration, silence, airframe assembly, partial response, then silence after 9 seconds. Propellant loading, full communication. He activated the emergency protocol and waited for instructions that took 43 minutes to arrive. The communications chain above him, processing information that it needed to understand before responding. The B-2 was past the Zagros range when the facility commander received his notification. The data link confirmation code had been transmitted at 1:46 p.m., accompanied by a supplementary transmission: the first weapon's penetration telemetry, the fourth density variation depth, and the aim point modification parameters that the planning element had requested for this mission's contingency. The planning element received it at 1:47 p.m. and completed the post-mission damage assessment 4 hours later. Production sequence broken at the 2 stages most critical to weapon completion. Surviving propellant without the infrastructure to load or assemble it did not represent a recoverable operational capability within any relevant timeline. The numbers: 15 hours and 27 minutes of flight time, 2 GBU-57 massive ordnance penetrators, 1 in-flight aim point modification based on first weapon telemetry, second weapon redirected to guidance integration chamber for direct contact detonation, 2 S-300 missiles launched on a single above-threshold range-ambiguous solution, both outside the lethal radius, 9 seconds of clear TOR-M, 1 frequency producing 2 below-threshold returns observed only in their absence, 4 meters of geological variance that shifted the first detonation above design depth and triggered the modification, 0 aircraft lost, guidance integration eliminated, airframe assembly extensively damaged, propellant loading structurally damaged, equipment non-functional, propellant intact but inaccessible to a sequence that no longer existed. A sequence broken at its most technically complex stages does not produce missiles that are merely delayed. It produces a facility with raw materials and no path through a process that no longer exists. The geological variance that shifted the detonation 4 meters was not in the planning. The decision it triggered was. The modification was right. The production sequence was broken. The plateau holds its silence and its distance. Both had protected the facility for 14 years, and neither had been enough.